Okay, what we have here is Algebra 2, 7.5. It's graphing square roots and cubed root graphs. And I'm going to introduce the parent, family, child of this. So we're going to start off with the square root graph. So our square root graphs look like this. What we're going to find is we're going to have a big, long square root graph that has a value outside of the square root that's multiplied. We got an h value that's added or subtracted inside the square root, and then something on the outside. Those are a, h, and k. And a, h, and k will all do something different on a graph. And so what we do is we need to graph this, and we're going to put layers. We're going to start layering it because the variables of a, h, and k affect a graph differently. And so what we need to do first is get rid of all of it. We're going to get rid of the a, the h, and the k. And if you do that, you end up with just the parent graph. And the parent graph is just the square root. What is the root problem or equation we have? And it happens to be a square root graph. And so I'm going to go back to the most simplistic square root we could ever have, and that's just the square root of x. And then from here, we're going to start to bring back layers. And the first layer is the family of graphs. And the family of graphs for a square root graph are ones that look exactly like a square root, not moved anywhere, but we're going to bring back the a value. And the a value is multiplied to the square root, which is multiplied to this graph over here. And if I multiply it to the square root graph, what it's going to do is it's going to get taller or it's going to get shorter. And so if I make it taller, it's going to be a vertical stretch of whatever a is. So if a is 2, it's going to be 2 times taller than the parent was. If it's a half, then it's going to be a shrink of a half. It's going to shrink down by that factor of a half. And then there's also something that's called reflected about the x-axis. And we're going to get to all these things and show some examples. That if a is negative, it doesn't open up, it's going to open down. It's going to be someone just knocked it over to the other side of the axis. And I'll show an example of that as we go. And so what we have is a family. And then, once we have a family, we're going to bring back the h and the k's. And actually, I'm going to change, or put the letter in here. This is an h, and this one will be the k. I put a space there originally. But what we're going to do is we're going to move. Now h, you can see, is with the x inside. It's always the opposite. So maybe I'm going to change colors again. And I'm going to put on here in parentheses, it's the opposite of what it looks like. So if you see something like x minus 3 inside the square root, it actually is telling you that it's going 3 to the right. You're thinking, oh, that's a negative 3, right? It's minus 3. No, I'm actually going to the right 3. If inside the square root you see x plus 3, that means you're going 3 to the left. It's because the formula way over here says it's x minus h. And so the only way for it to be x minus 3 is if h was positive. That's why you're going to the right. If it's negative, you're subtracting a negative, which means you're adding. So therefore, you're going to the right, left. So h is with your x's, and the x direction goes left and right. So that's why we have a left and right movement. K follows your y direction, and that's why you go up and down. K is exactly the way you see it. K is one of those things that's happening at the very end of something. So you go to work, you make all your paycheck, you make all your money, and then all of a sudden you get home, and mom and dad said, here's $5. Your income or your money just went up. You get home, and they say, hey, you owe us $20 for that t-shirt you bought. Oh, well, my money goes down. So K is like that thing that happens way at the end. It's after everything was said and done. If it's positive, it goes up. If it's negative, it goes down. So what am I going to do with all these numbers? It's great. This is a lot of information on here. To make it simplified, we're talking about square roots. Normally, if I give you a square root graph, you could just make a t-chart. Throw some numbers in, plot it, boom, there you go. But your problem is that square root graphs, they start someplace and then they go forward. Square root graphs, think about it. Can you take a square root of a negative number? No, you can't take a square root of a negative number. So therefore, you can't put any negative numbers in here. So you got to think, wait, what's the smallest number that I can take the square root of and still get a number? 1 will work. There's actually one smaller than that. 0. So 0 is the smallest number that if I take the square root of 0 is 0. And from there, I have to go in the forward direction, right? Positive direction. So, don't write these down, but 1, 2, 3, 4, and so on, right? Now here's the problem. What's the square root of 1? 1. Okay, that's not a problem. What's the square root of 2? It's a decimal. You want to graph a decimal? I don't want to graph a decimal. What about 3? Not a nice number. Is 4? Yes. So, guess what? Since it's my t-chart, I'm going to choose what I want to put in. And so I am going to choose perfect squares. I'm going to purposely put in ones that are going to turn out to be nice numbers, like 4. 4 becomes a 2. 9 becomes a 3. This is never going to change for a square root graph. I will always use those 4 numbers. Now, what I'm going to do then with this starting point, because this is a parent, all parents stay at home, that means that I'm going to base everything off of this. So how does it all work? Well, look, I'm multiplying a times the square root of x. Wait a minute, the square root of x. These y values are the square root of x. This is right there. So what I'm going to do for here, when I go to make this t-chart, that t-chart right there, my x values will stay the exact same. Nope. 4, 9. Those values stay the same from here to there. What changes is I am going to, as I move this way, is I am going to multiply the y's by a. So when you're going this way, all I'm going to do is take these y values and multiply them by whatever this a value is, and I put them here. So, for an example, if a was 2, your graph, up here we have to state it, if it's a 2, it's a vertical stretch of 2. But then when we come down to our t-charts, I'd say 0 times 2, which is 0. 1 times 2, which is 2. 2 times 2, which is 4. And 3 times 2 is 6. That would give me the values for here. Now, moving on. Moving on to the child, we bring back h and a k, which means I'm translating, aka moving left or right h units, or up and down k units. So what I'm going to do for this t-chart, for here, is I'm going to add or subtract h. I'm going to add or subtract k to those values. What values? The ones that came from this t-chart. I'm moving this t-chart, the middle one, the family, to get to the child. I'm just going to add h or subtract h. If I'm going to the right, I add. That's going in the positive direction. If I'm going left, I'm going to subtract. That's negative direction. If I go up, I add. If I go down, subtract. Okay? This t-chart here, that results here, you graph those, you're done. So the whole goal is to get to this t-chart. And here's the cool thing. Square root graphs, I'll put it on the bottom, look like this. This is a parent graph. It originates at the origin and moves up. That's for this one. All I'm going to do is pick that graph up. I'll try my best here to lasso it around. Okay? I pick this up, and I'm just going to move it. So if it's moving this way, moving that way, this way, I might even stretch it so it gets stretched out. That's all I'm doing. That's what I'm doing with each one of these steps. I'm stretching it or shrinking it, and then moving it left, right, up, down. All from the yours. So let's start off with our first one. This is 2 times the square root of x minus 1 plus 3. So what we're going to do is we're going to graph this together. And the first step is find its parent. What is the parent graph of this whole entire thing? What's the underlying graph? Y equals square root of x. It's a square root graph. And since it's a square root graph, I am going to make a t-chart with what in it? Perfect squares. 0, 1, 4, and 9, which ends up being 0, 1, 2, and 3. Not going to change. Never. Now, we're going to go to the family. Family brings back the a value. What's a? In our particular problem. Now, it's a 2. So it's going to be 2 times the square root of x. Now, if something gets twice as big, it's going to be a vertical stretch. Right. So we go to our bridge, and I want to say vertical stretch of 2. Now, this is where if a was negative, so if it would have been a negative 2, I'm going to put it on, but I'll take it off. If this would have been a negative 2, we'd still multiply it by negative 2 on the family part, but we would have to add one more line in there that says reflected about the x-axis. We're still going to multiply it by a. Nothing else changes. It's just a couple extra words to help us identify that the graph, instead of opening up, like instead of like this, it opens down like that. So, that's not what we have. Going here, we now have to go to our t-chart. And if I'm going to get 2 times taller, does it affect my x's at all? No. So they stay the same. 0, 1, 4, and 9. But it does affect my y values. It makes them all twice as big. So I go over here, and I multiply all of these by 2. So 0 times 2? 0. 1 times 2? 2. 2 times 2? And 3 times 2? So that we now have our family. We now can go to the child. And the child is the whole entire equation that's in question, which was 2 times the square root of x minus 1 and plus 3. So where is this graph going? In words, where is it going? We've stretched it by 2, vertical stretch of 2. Now we have to worry about the h part. It's 1. We're moving it 1.
Right.
We're moving it to the right. So we are going to say it's translated 1 right. Because it looks like it's going negative, but it's the opposite. And the 3, we'd say it's translated 3 up. And if I go to the right, does that affect my x's or my y's? The x's. So I am going to take these x's and do what to them? I'm going to pick them up and move them to the right one. So if I start at 0, I'm at 1. I'm going to add 1. If I'm at 1, I'll end up at... If I'm at 1, pick it up and move it 1, I'm at 2. If I'm at 4, I end up at 5. I'm at 9, I'm at 10. I just moved, or added 1 to all my x's. Now, we get to the y's. I have to go up 3, which means I'm taking all the y values and add 3. So if I'm at 0, I'm at 3. If I'm at 2, 5, 4 becomes a, and 6 becomes a 9. Here's another cool thing. You'll recognize that this point, 1, 3, are actually our h and k. That's kind of the cool thing about that. 1, 3, and then hk is always our starting point of our child. So when we go to make a graph, because this is all we have to graph now, I have to go here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go up 2. So 1, 3 is about there. That's our starting point. 2, 5. 5, 10, 1, 2, 3, 4, 5, 7, 1, 2, 3, 4, 5, 7, and 10, 9. A square graph is not a line. It starts at your first point, goes up from there. It will continuously go up forever, so it goes towards positive infinity for y as x goes to infinity. But that is your square root graph. Now, just for fun, you don't have to graph this. I'm going to graph the parent on here too. That was 0, 0, 1, 1, 1, 2, 3, 4, 2, and 9, 9, 3. That's the parent. As you can see, that it definitely looks like it was stretched vertically. It's a little bit larger of a span, and everything's been picked up and moved 1 to the right, 3 up. That's what it is. That's all it is. So without having to do the whole thing again with a cubed root graph, a cubed root graph does look pretty close to the same. The only thing is that instead of using a square root, they make it a cubed root. Everything else is the same. A affects the graph the same way, H does, and K does. What you need to do then is say, what's the parent? Because once I establish what the parent is, I can multiply to the y's, I can add to the x's, and I can add to the y's. Everything else stays the same. So the parent is now not a square root graph, but a cubed root graph. And so, this t-chart, though, has negative values. Because I can ask you, what's the cubed root of negative 8? It's not 2, but it's negative 2. Remember, cubed root graphs always have an answer. So, cubed root graphs, 1's a perfect cubed, 8's a perfect cube. I'm going to deal with perfect cubes. But since I can go negative, I have to have negative 8, negative 1, 0, 1, and 8. This will never change. What's the cube root of negative 8? Negative 2. Cube root of negative 1? Negative 1. Cube root of 0? 0. Cube root of 1 and 8, respectively. From here, you build the rest of it. What do these graphs look like? These graphs look like this when you graph them. That is a cubed root graph. So if you were to graph the parent, you would see this. So when your graph is done, you're going to stretch it. So that means it gets a little bit taller here, a little bit taller there, or you shrink it, and then you move it left, right, up.